Dear students, we are in lecture series of Theory of Computation, and we discussed DFA, and we also discussed minimization of DFA in the last few sections. Now we are going to discuss about regular language and not regular language and how to find out whether it is regular language. The definition is, in case if you have a finite automata, and if that finite automata accept a language, then that language is called regular language. The languages accepted by the finite automata are called regular language. Who is finite automata? DFA, NFA, epsilon NFA. All comes under finite state machine called finite automata. If a language is accepted by finite automata, then it is regular language. In case if it is not accepted, then it is called not regular language. The languages which are not recognized or accepted by finite automata are called not regular language. Why it is so? In case if you have a finite automata, it doesn't have a big memory. It is highly having limited memory. What is that, sir? It can store only the present state. What it means? Assume that I am standing at state B. If you ask me, you are in state B. If I give 0, where you will go? I will go to C. I am in state B. If you give input 1, where you will go? Self loop. That much only I know. We call it limited memory. Will I have a knowledge about A transition when I am standing at B? No, it doesn't have a memory. And it can't even count also. It have a loop, but you cannot say count for 10 times. 1, 2, 3. No, it doesn't have. Okay. It will do only instantaneous. At state B, it can store only the transition for the next alphabet, either 0 or 1. Not about A state or not about C state. So it is called limited memory. In some particular languages, let us say 0, 1, 1. If I want to implement in DFA, 0, 1, 1. Possible. No need of memory, DFA can be implemented. Hence, it is a regular language. This language is a regular language. In case if I have a language like this, 0, 1, 1, 0, 1, repeat, 0, 1, 1, 0, 1, repeat, 0, 1, 1, 0, 1. Sir, I am sorry, sir. You are counting 3 times. So, it is not possible. So, 0, 1, 1, 0, 1 is repeating 3 times. So, we don't have a memory for that particular process. A power n, B power n. How many times, sir? N number of times A, n number of times B. Let us take n is equal to 4 or 5. Then 4 A's, 4 B. N is equal to 4. Now, can you implement? No, sir, not possible. Why? Who is going to count 4 times? Your DFA cannot count. Here we have to count A's and B's for 4 times. Keeping that count is not possible. So, this language and this language is not regular language. This language is regular language. These two are not regular language. We need a procedure to find out not regular language. Why? In case if it is not regular, you can't implement in finite automata. So that is the reason. We need a procedure to find not regular language. It is called pumping lemma. It is a very simple procedure. We will have a glance. Assume there is a language AB. Double A, double B, triple A, triple B. The moment you see, you know that it is not regular because count is required. In this particular language, take any one string, preferably some 4 or 5 R. Don't take minimum, it is very difficult. I am going to take a string which is having 5 A's and 5 B's. Let it be. What is the procedure? This string is having 5A and 5B, that is n is equal to 5. This string, split it into, chop it into 3 category X, Y, Z. That's called group W into 3 sections X, Y, Z. Like this I grouped. First letter A is called X. 3 letter A's are called Y. Remaining all are called Z. Sir, in what basis I did this grouping? Can I have different group? Yes, you can have. In what basis you did grouping? With some simple logic, we will explain in 2 minutes. This is X, this is Y, this is Z. Let it be. Once it is ready, The middle term y, pump. What do you mean by pump? Repeat. Pump at least I times. Y portion of the string is called minimum, a small portion. Lemma means minimum. And you take that minimum portion and pump, called pumping lemma. Now I have taken I is equal to 2, which means y term I am going to write 2 times. This is x term. This is y term. I wrote 2 times. This is z term. Now the conclusion. Is it available in the language? No sir, no sir. 6a, 7, 8 a's, 5 b's. Sir, it is violating the language. So, since this w is not in the language, condition for regular language means it must exist in the language. But since it does not exist, string does not exist in the language, hence the given language is not regular language. That is what we are trying to say. Now, what is the condition? On what basis you did this, sir? L is a language, you know. W is a string, you know. N is constant, that is count, you know. The total W, whatever the term you take, should be greater than or equal to N. Obviously, it will be. 2 major steps, X, Y, Z. How you are going to split? X and Y put together should be less than your N. I am having 5. It should be 5 or less than that. Right now it is 4. That is what the idea. And the minimum Y term must be there because we have to pump, you know, that is what Y should be greater than 0. After doing this pumping, if it does not belong to the language, then it is not regular. We'll do the same work as a problem. A power n, b power n. Let us take n is greater than or equal to 1. And I have to prove it is not a regular. Now take some language and then you take one word with n is equal to 5. I took 5 a's and 5 b's. Step 1, split it into x, y, z. How you are going to do? X and y put together should be less than 5 and y term must exist. Ready? X, y, z. Completed. Step 2, y term I want to pump. How many times? 2 times, 3 times, 4 times, any number of times. So I taken a equal to 2. So I made it. Now this word, is it belongs to this language? No sir. The W does not belongs to the language. Does not belongs to the language. Hence it is not regular. That's all. I will show one more problem. A power n, b power 2n, where n is greater than or equal to 0, is equal to 1. I want to prove that it is not regular. Let us take this particular a power n, b power 2n. I will take different values of n. 1a, 2b, 2a, 4b, because double, 3a, 6b. Okay. Now n value is 3 here. Okay, let it be. Now I have taken n is equal to 2, something like this. I want to split x, y, z. If I split, since I took this term, n is equal to 2, I should not exceed n value, x, y put together, 1x, 1y. Now who is x, y put together is only 2 value. It is less than or equal to n. The condition satisfied. Now I just split it into x, y, z. That's all. Y term, I should pump I number of time. Usually I will take I is equal to 2. I can take I is equal to 3 also, 4 also. I repeat it. So this green color A, I should write 3 times. Done. Now what is the conclusion? 4A, 4B. Sorry sir. It should be 4A, 8B's. Okay, it is not satisfying. So the given W does not belong to the language. Hence it is not regular. We can have one more problem. A power R. What is R indicates? Reverse. R indicate reverse. Whatever the term A, second portion is reverse of the A. The first half is reverse to the second half. Now I would like to take zeros and ones. Just have a look. By 2 you do. 110 reverse 110. Okay, reverse. 1101 1011. You can just do reverse. That's what. If you do by 2, it's a reverse. Okay, that is what the story. Now I would like to take one particular group. 110 is n, 011. That is reverse. I have taken 3 terms, that is n is equal to 3. Split it into x, y, z. Make sure that x, y put together less than 3 is then or equal to 3. So first term is x, another 2 term is y, remaining is as it is. If you want 1, 1, 0, 0, 1, 1 also you can take. Okay, remember. So that is not 1, 1 is x, 0 is y, allowed. 1 is x, 1, 0 is allowed. 1 is x, 1 is y, remaining all are z, allowed. Make sure that x, y put together should be 3 and less, and y term must exist. That's all. Now let us pump for 3 times. That is 1, 0. I am going to repeat 3 times. 1, 0, 1, 0, 1, 0. Done. Now what is your conclusion? Make it half. Is it first half is reverse as second half? No chance. So it does not belong to the language. Hence it is not regular. I have shown some problems to prove that given problem is not regular using pumping lemma. In case if I is equal to 3 not satisfying, you have to go for I is equal to 4, I is equal to 5. With this, I would like to conclude this particular pumping lemma to find out whether the given problem is not regular. Thank you.